And this one we're going to go through how to do the square root. Now the square root, like the three famous problems, cannot be done just with a compass and straight edge. You have to use a form of the insertion principle because you have to use a unit of 1 to be able to construct it. And that's one of the reasons why square roots gave the Pythagoreans so much of an issue. So first thing, you need to start with the segment. I'm going to do one of a given length just to verify that it works for you. So I'm going to use a given length of 4 because I know that the square root of 4 is 2. Makes life easy. Now the next part I need is to create a segment BC that's of unit 1 on the outside of AB. So to do this, the easiest thing to do is to actually create a line through AB. And then I'm going to use a circle with center and radius. And if I make that radius be 1, I can now put that point C out here on the outside of my segment. And now I can just hide those other options. I'm just right clicking and no longer showing the object. And I come back and draw in my segment. So I have AB, which I know is 4. I made it that way. It doesn't have to be made that way, but I'm just trying to make life a little easier on us. And then the single segment that is 1 unit. Now I need the midpoint of this larger segment, which I could do with my classical tools. I click on, but I'm going to do it the quick way and just use the midpoint formula or midpoint tool that's built into GeoGebra. Speed this up a little bit. So I'm going to then create a segment or a circle with circle D to point A. Then if I make a perpendicular line through B, again, I can do that with the classical tools. I can make a perpendicular line through B. I'm just going to speed up by using the perpendicular construction. What I know is if I put a point here for E and I measure that segment, so if I go and do distance or length, watch what I know about EB. It's the square root of AB. And why is that the case? Well, let me complete my image here. If I look at AEC, that's a right triangle with the altitude through the right angle, and that is formed by using the geometric mean, where I know, sorry, let's go to pen, that AB over EB will equal EB over BC. Well, AB we could say so, and I know though that here I made this 1. So this means that AB equals EB squared when I cross multiply. So the square root of both sides. So now I know that EB has to equal the square root of AB no matter what length I make segment AB. I just use 4 to verify and show you that it is the square root. Now, that insertion part of making BC be a measurement of 1 is what causes the problem, though, of why we can't say this is done with the classical tools.